we have covered a lot of ground with energy. Now we're going to just finish it off. So this is a video about the work-kinetic energy theorem. After this, we have just one more topic with energy. Okay, when we did energy conservation, we said energy initial equals energy final. We then added in non-conservative work. Non-conservative work plus energy initial equals energy final. And that's solid, and it works out every time. There is a question though. Can we add in work done by conservative forces? Surely a conservative force can do work also. And it can. What we have here, non-conservative work plus potential energy initial plus kinetic energy initial equals potential energy final plus kinetic energy final. Now, if I move my kinetic energy terms to the same side as each other and my potential energy terms to the same side as each other, I get something that looks like this. Non-conservative work plus PE initial minus PE final equals KE final minus KE initial. This thing, a final minus initial, that's a change. This thing, if I reverse these, I get final minus initial. So this would be a change in potential energy, but the order's backwards, so I'm going to put a negative. The work done by a conservative force is equal to exactly this. This is the work conservative. And I want to show you this. Let's say I have a ball up here, and I'm going to move this thing downward. So I've got gravity as my force. I'm going to move this through some height. The force from gravity is equal to mg. So the work done, if I'm moving downward, is going to be mg times the distance that I travel through, which is h. If I look at my potential energy, and I need a spot that I'm going to call 0, I'm going to call the ground 0, my potential energy initial is equal to mgh. My potential energy final is equal to 0. So my change in potential energy is a negative mgh. The work done by my conservative force, by gravity, is equal to the opposite of the change in potential energy. So then what this looks like is a broader definition. I have non-conservative work plus conservative work equals my change in kinetic energy, and that is my work-kinetic energy theorem. The initial kinetic energy of my system plus all the total work done by every force is equal to the final kinetic energy of my system. That's it. It doesn't really add anything. I will say that. It doesn't really add anything as far as a new way of doing things, right? Or as far as like an alternate way of doing things. Anytime you're doing the one thing, the one formulation, you're kind of doing both. So this is only helpful in the sense of recognizing, yes, conservative forces also do work, and we can write our energy equations in terms of that work as well.